Ladies and gentlemen, here is our lesson summary for lesson 12. In this lesson, we introduced the idea of congruent polygons and being able to tell when polygons are congruent and what we need to look for to see if they are congruent. Okay, so today's goals is we can decide using rigid transformations whether or not two figures are congruent. So if two figures are congruent, then that means that there is a rigid transformation that moves one figure to the other one. And we're going to see that right here. Okay, so now here we started off with this problem, and you see all of these triangles are rigid transformations, so they are all congruent. We were just focusing and looking on which ones are a translation. Remember, a translation is when you move the figure without turning it. So these three, you can't see this one because of my head, but these three are translations. So that means that they are congruent to the original triangle. All right, so now we're going to decide by looking at these which ones are congruent. Remember, what are some things that we look for to see if they are congruent? If you look at this right here in figure number 1, you see that it is a rotation. This figure is rotated 180 degrees around the center O, so that means that it is congruent. If you can describe the transformation, then it is congruent. Now look at number 2. In figure number 2, you can see the shapes are not the same, so it is not congruent. Okay, number 3, you look at figure 3. This one is also a rotation. You can also look at the sides. This side right here is 2. The corresponding side here is also 2. This side right here is 2 by 4. So if you look here, it's also a 2 by 4. So that is congruent. And then the fourth one, this is the one that a lot of students were a little bit hung up on or made an error, is if you look at these two figures, they are the same shape, but you notice that they are different sizes. So right here, NM, the side that corresponds, FE, is smaller. So when you do the transformation, it is a little bit bigger. So it is not congruent. Remember, they need to be the same size for them to be congruent. All right. When two shapes are congruent, there is a rigid transformation that matches one shape up perfectly with the other one. So when we were using Desmos, we were able to match up the shapes. So like we said, if you can describe it and saying, oh, it's a rotation this many degrees around the center, then that is enough to say that it is congruent. When two shapes are not congruent, there is not a rigid transformation that matches up perfectly. So if you were to translate this octagon over this one, you will see that it does not match perfectly because they are different sizes. Okay, we'll just do a quick one here. Out of these right here, we'll see which ones are congruent. If you notice this one, you can look at the sides. These are congruent. This is 2, this is 2. All the sides match up. This is a rotation 90 degrees. Okay, if you look at the next one, this is not congruent. You can see that the sizes are different. Right here, these are congruent. This one is a reflection. You see, you can just reflect here. The line of reflection is right there, and then translate. And look at this one. These are not congruent. You see the angle here is different. The corresponding angles are different. The side lengths are different. And then this one here was one that was a little tricky. We actually had to measure and do the rotation, and you'll see that these are not congruent because this one right here is a little bigger than this side right here. And you can do that by rotating and then translating. Okay? In order to be congruent, polygons need to have congruent sides, congruent angles. And the congruent sides and angles need to correspond in both figures. So you saw that in the examples, even though they may have the same sides, the angles may be different. If they have the same angles, the sides may be different. Okay, our big ideas. We have 4 for today. When two figures are congruent, when there's a sequence of transformations, meaning you can rotate, reflect, or translate to move one figure on top of the other one. So that's enough to say that they are congruent. Big idea number 2, when showing that two figures are congruent on a grid, you can use the structure of the grid to describe the rigid motion. So you can say, I translated down units. I translated to the right. You can also use the rotation and seeing how many degrees when you are looking at a grid because you're able to talk about measurements. Two figures are not congruent if they have different side lengths different angles or different areas. If you're able to find one thing that is different about your two figures, then they are not congruent. They need to have everything the same. All right. And number 4, even if figures have the same side lengths, they may not be congruent. Okay. We saw that in the one where it was a square, and then the other one was a rhombus, where it was a little slanted. Okay, example with 4 sides of the same length, we can make a rhombus or a square, and they have different angles. Okay, so today's goals, we were using the rigid transformations to decide whether or not two figures are congruent. If you can describe it and say it's a rotation, it is a translation, or a reflection, or combine them, that is enough to say that they are congruent. All right, thank you.